Hello everyone, I'm Amir Hossein. In this video I will show you how to calculate water index from sentinel2 data. Search for sentinel water index and open the first link. Here you have several guidance that discusses how to calculate water index for several different satellite sensors. The first one is water index for sentinel2, and the next one, the second one is, for example, for the Landsats 1 to 5, Landsat 4 to 5, and the last one is water index calculation for MODIS. But what is water index? Water index is an index between -1 to 1, and the closer the index to 1 means that the possibility of water will be higher. So generally the values more than or higher than 0.5 or half can be considered as water. So for Sentinel, if you see the formula here, we need two bands, band 3 and band 8. Band 3 minus band 8 divided by band 3 plus band 8. And both of these bands, 3 and 8, are available as 10-meter resolution. So it means that we can generate, or we can make water index as a 10-meter resolution image. Let me go to terminal. So here I have 4 data files, and they are band 3, band 8 for one data set for one tile of Sentinel, and another band 3 and band 8 for the other data or tile, Sentinel tile. And I have a Python code here. Let me open this Python code. And this Python code, in this Python code we use RioXArray, which is a Python module based on XArray that is used for raster analysis. Let me open another tab and let me run Python interactively, and I just want to run this code until this line, because I want to discuss about some data type conversion here. These are critical points about data conversion. You can see that it is needed to convert the data, the initial data type, to some other data, and it's necessary, and I'm going to discuss it here. Okay, I load RioXArray module as Rio. I renamed it as Rio, and also have another module for merging two data sets, which will be used to merge two data sets, and two arrays, I mean, which will be used to merge two final arrays. And we have here numpy, and also here we have loaded, or we have read one of these data, which was 10-meter resolution, band 3 as 10-meter resolution, and band 8 which is also as 10-meter resolution. So band 3 and band 8 has been written here, and if I print band 3, if you pay attention to the data type of this band, you can see that it's as unsigned integer and 16-bit integer. And you should pay attention that using this data type in some calculations that need a float data type is not recommended, because you will end up wrong values. So it means that if I put if I do my calculations, let me copy it, put it here. If I do my calculations without these conversions, I will reach to wrong values. Pay attention to the left side of the equation. We have the equation here. Where is the equation? This is the equation, sentinel2 water index. It has two sides, left side and right side. So the left side should be as float. This is the left side. If I want to make it as a float data type, I have to convert it to a float data type. So if I convert the first array to float data and subtract it from another array, I will reach to a float data. I don't need to convert the second array to float because the first array has been converted to float, and that's enough for that. And for the right side, I need both of these variables, b3 and b8, to integer as 32 bits, because if you sum two integers as 16 bits, you will reach to you might reach to values that are outside of the capacity of integer of 16-bit integer. So you need to convert it to 32-bit integer, and after that you will reach to the water index between -1 and 1. So just let me run this code. This was actually for the first data file, for the first tile, and this one is for the second tile, sentinel tile. And after that, both of these files, water index, second water index and first water index here, they will be merged. First water index and second water index will be merged, and by this functionality, both of these tiles will be merged as one data file. And after that, the final array will be saved as water index GeoTIFF data file. Let me run it, water index. It is writing water index. This is for the second data file. We had two sentinel data. Merging them. Takes a couple of seconds. And now I have water index as GeoTIFF data file. I can show it by, I can display this data file by QGIS. Let me just read it. And GIS water index TIFF, and this is the merged. This is the final product that is that is generated, that is made by merging two data arrays. And you can see that the values are between -1 and 1. You can make it colorful, and here with deep blue are actually water. Outside of these area and that have less values, they are less likely to be water. You can use the same method to make other indexes.